Hello and welcome to this video. So in this video, I'll be discussing static NAT, static network address translation. There are four different implementations of network address translation: static NAT, dynamic NAT, NAPT, and EZIP. EZIP is a special implementation of NAPT, or also called PAT, put address translation, and then NAT server. Now, in this video, I'll be discussing static NAT, and we shall see dynamic NAT, NAPT, EZIP, and NAT server in subsequent videos. So what exactly is static NAT? Well, in static NAT, we do one-on-one mapping. A private IP address is mapped to a fixed public IP address. It provides for bidirectional access. What this means is that a host on the internal network can proactively access a server on the internet, but at the same time, a host from the public network, from the internet, can proactively access a host on the internal network or a server on the internal network, because one private IP is going to be mapped to one public IP. One private IP is going to be mapped to one public IP. One private IP is going to be mapped to one public IP. So what's going to happen is that when 192.168.1.1 tries to access the internet and send its packet to this egress router, the egress router will check in its NAT mapping table and see that the 192.168.1.1 has been mapped to 122.1.2.1. It will do the conversion, and the outside server we are attempting to access will see a packet as it comes from this guy and not from this guy, because this guy here cannot be allowed to access the public internet. Let's look at the implementation of this. So let's say host 1, in this case 192.168.1.1, tries to access the server at 200.1.2.3 outside on the internet. What's going to happen is that when this packet reaches our NAT device, which is normally the egress device that connects our intranet to the internet, the NAT device will convert the source IP 192.168.1.1, will convert it to 122.1.2.1, and the destination will remain the same because it's a public IP address. And this packet will be sent all the way to the destination, which is the web server. When the web server replies, obviously the web server is replying to the one that it received from. So it sends a reply from itself. It sends a reply from itself 200.1.2.3, which is its IP address, and it's sending it to the IP address that contacted it, 122.1.2.1. When the NAT device receives it, it's going to check in its NAT mapping table again. We saw this mapping table on the previous slide. It will check in its NAT mapping table again and say, oh, this 122.1.2.1, that guy was mapped to 192.168.1.1, and so it will do translation again. It will translate this time this destination IP, which is an IP somewhere in the pool of in the table right here. It will translate it back to this IP, and so our traffic, our return traffic, will come all the way to the actual device that attempted to access. Now we present the exact same analogy, this time with the traffic coming from an external host. When an external host starts the access, it is trying to access 122.1.2.3, and the external host is that guy right there accessing. The NAT device is going to convert that address to an internal address based on the mapping table. Again, based on the mapping table, it's going to be converted to an internal address, and when the internal host sends the reply, again, there's going to be conversion at that point, the NAT point, the network address translation point, to the actual outside address. What that shows us is that right here on the outside network, on the public network, it's actually just public IP addresses in exchange. But when you look at the internal network in the intranet right here, you realize we have our private IP addresses being used safe and sound with no problem at all. That is one-on-one. Each private IP is mapped to each public IP. But realize that kind of doesn't solve our first problem really well. Our first problem is shortage of IPv4 addresses. And if each IP address is mapped to each IP address, then it's going to be a problem. We are really not saving, but there is still the security bit is still there, and we are able to speak to the outside world, and more so, this is bi-directional, so it kind of works. There are other implementations of NAT that do not use a lot of IP addresses like this. Well, for static NAT, since it's what we started with, let us look at the basics of the configuration. So you can configure static NAT in the interface view or configure it in the system view. So you use the command NAT static global and then specify the public IP address inside, then specify the private IP address. The global address is used to configure the external public IP address, and the inside address is used to configure the internal private IP address. You can also specify NAT in system view. You say NAT static global and specify the global address inside and specify the private address. You can use either of these, but the idea is when you finish configuring this command, you've set up a pairing. You've paired a public IP, and the private IP that translates to it. That's the purpose of this command. You can configure that at an interface or in the system view of the device. Now, you will need to go and enable NAT on the interface on which you want NAT to be terminated by using the command NAT static enable. Enables the static NAT on the interface. This is an example configuration. You can see this is a similar network that we just had previously. We have in our private network 191.6.1.1/24, 191.6.1.2/24, and 191.6.1.3/24 connected to 191.6.1.254 as their default gateway on the egress device. The egress device will need NAT configured. On the outside point, the egress device has 122.1.2.1, and of course we have our mapping table that we shall need to configure on this device. The mapping table has the private IP mapped to the public IP. So we will have the IP 192.168.1.1, then .1.2, then .1.3, and these are mapped to 122.1.1 and 122.1.2.2 and 122.1.2.3. Like that. That's the mapping that we're going to have. So how do we configure this? We can go to the interface right there, interface gigabit and 0/0/1. That's the interface you want to terminate NAT. And then we do IP address. First, give it its own address. And then we start NAT static global. We said this global address should be mapped to this internal address. This public address should map to that private address, and that public address should map to that private address. Once that is done, we have set up our mapping table inside of this device, and when it receives a packet from that address going to the public network, it will convert the source address to the address that is mapped to that specific address based on the NAT mapping table. When it receives a packet from this, it will convert it, and so on and so forth. Now, all this works really well, except that it kind of still wastes IP addresses, and the fact that only 3 users can access the internet at a time, and not only at a time, but can actually access the internet. Even though this guy is not communicating, he's not using the internet at any time, he didn't go to work today, he's not using the internet, no one can use the public address mapped to him because that address has been statically mapped to him. It cannot be mapped to another person that needs to use the internet. Only this guy can use that address because it's specifically mapped to him. Each person can use one IP address for for communicating to the internet, and that address is mapped to them. So that is the implementation based on static NAT. I hope this has been informative for you. Thank you for viewing.